All right, this is the last set of notes for this chapter on stoichiometry. And again, I know this is a really hard chapter. All right, this last set, actually the math is pretty easy because we're actually going to jump all the way back to the very beginning of this chapter, and we're only going to do moles to moles. That's it. You don't have to do mass, you don't have to do volume, you don't have to do counting or anything like that. You're just going to do moles to moles. But, I know, it has to be a but done there. But the bad part about it is this one also makes you have to think. You have to apply the concept of what in the world is going on inside of this chapter as to what we're looking at in regards to the calculations of stoichiometry. Right? And that's what makes this one really hard. But the calculation part, the actual math part of it, is pretty easy. Right? So you got to follow me on this and see how this works. So in your notes, we're given this balanced equation, making water. All right? So we're using this really simple little balanced equation. And then it says that we are given two things. You're given that you have 7.3 moles of H2. So I have 7.3 moles of H2, and I got 4.2 moles of O2. Now wait a minute. There's no X in this. I've always written an X above one of them. Well, this time I got a number on both of them. Well, that really makes it confusing because we don't have an X. Now, what we're trying to find out is what is the limiting reagent. In other words, which one of these two is going to control how much of this over here can be made, right? One way of looking at this is like going way back to the very beginning of this chapter, right, and we talked about making cookies. And if you remember, we were talking about chocolate chip cookies, and I had that recipe. Remember? Recipe, right? And I told you that we had a whole bunch of flour, we had a whole bunch of sugar, and we had a whole bunch of salt, but we only had a quarter cup of chocolate chip cookie or chocolate chips. And so which thing is going to control how many cookies we can make? Well, it's not the flour because I got gobs of that. It's not the sugar because I got a whole bunch of that. It's not the salt because I got a whole big container of that. It's that quarter cup of chocolate chips. That decided because I needed to have a half a cup. I only have a quarter cup. So that's going to control how many cookies I can make. And it turned out, remember, it would make 24 cookies. Well, because I only had half of what I needed, I could only make half the amount of cookies. So instead of making 24 cookies, I can make 12 cookies, right? That's what this part's all about, is what's the controlling factor. Now, I wish we could just talk about chocolate chip cookies, because that makes this so much easier. But we can't. We got to talk about chemistry stuff. When we throw in that chemistry stuff, oh my gosh, then it becomes nasty, doesn't it? Right? Well, in doing this, what we got to do is we have to make one of these two things an X. Does it matter which one? Nope, doesn't matter. You get to choose. You can choose either one, right? So let's see, which one did I do first? Select one of the reagents. Ultimately, and in my notes, it says I'm going to do both. You don't have to do both, all right, when you do these as homework. But I'm going to do both so that you can see that it really doesn't matter which one you choose. You'll always get the same limiting reagent, right? So we're going to select the 4.2 first. So we're going to take this guy, and I'm going to put a green X on top of it. So in other words, we're ignoring the 4.2 right now. And we're going back to the very beginning of this and going, well, they gave me 7.3. And I want to know X moles of O2 that would react with. So in doing that, we need a balanced equation of 2 moles of H2 will combine with 1 mole of O2. All right. Then we go, well, I don't have 2 moles of H2. I got 7.3 moles of H2. And I'm trying to find out my new X moles of O2. I'm trying to keep my colors the same, at least on this part, the setup piece. So this part came from the balanced equation. This part came from the question. And this one was my new X that I produced. I made that into X because we're ignoring the 4.2 right now. Right? Now all I got to do is cross multiply and solve. So 2 times X equals 1 times 7.3. Get X by itself, so divide both sides by 2, and X ends up equaling goodness, I'm sorry. Oh man, okay. I made a mistake. Sorry, and not a mistake, really. What I've done is I've done the second half of this. So we're actually down a little bit in the notes. Right? because we're using the 7.3 and made the 4.2x. Okay, so in your notes we're down a little bit lower. All right, sorry about that, but I'm gonna end up with 3.65. That's why I was like looking at my answer on here isn't right, but it is. So if you multiply this thing out, you're gonna get 3.65 moles of O2. So this number up here is 3.65 moles. So what that says, it says if I use all 7.3 moles of this, I need 3.65 moles of O2. Do I have that? Yep, I sure do. And I got a whole bunch extra, don't I? All right, I've got 4.2. I only need 3.65. So that means this guy right here, and I'm going to circle him in green. This guy is my limiting reagent then. He's going to run out first, even though, and this is when it gets confusing, well, that's the bigger number. Doesn't seem right. Seems like the smaller number should. But remember, it all has to do with this ratio that's going on here. I need double the amount of H2 than I need of O2. Right? So don't automatically think it's always the smaller number, because sometimes it will be, sometimes it won't. So that doesn't count. You got to do these ratios in order to figure them out. Right? All right, so now let's do the first one. Right? Remember I said you don't have to do this twice. Right? I'm just going to do it twice to show you that it doesn't matter, that either way you can still get the same limiting reagent. So this time we're going to make this X. All right, so this time we're going to ignore the 7.3. We're going to use the 4.2. So I'm still going to have the same ratio, 2 moles of H2, or 1 mole of O2. That came from the balanced equation. All right, and then we go, well, this time I've got 4.2 moles of O2. And we're trying to solve for my new X of X moles of H2. All right, so now again, we've started all over. Ignore what we did over here. It's like we've started again. We're trying to find that limiting reagent. We want to find out, is it still going to be that H2 that I found last time? All right, so we're going to cross multiply X times 1 equals 2 times 4.2. Multiply that out and you get 8.4 moles of H2. All right, so it says we got 8.4 moles of H2 that we're going to need. So if I use all 4.2 moles of O2, I need 8.4 moles of H2. Do I have that? No, I don't. I'm going to run out. I'm going to run out of H2 before I ever get up to 8.4. I only got 7.3. So that means this guy's going to run out first. Oh, hey, that was the one we ran into last time. That was my limiting reagent last time. All right, so it still shows me that H2 is limiting. So it doesn't matter which one you make X. You'll always end up with the same limiting reagent. Right? Your thought process to get to it might be a little different, but it's still going to give you the same limiting reagent. All right, so that was the first part of the notes. Then it says we got question number 2. It says, how much excess reagent will there be? Well, so excess reagent, well, this guy over here, this guy was the one that was going to have extra, right? Instead of I use all 7.3 moles of this, I need a certain amount of that. So I'm going to get rid of this number up here, because it came back to this number, and the idea that I'm going to use 3.65 moles of this. So how would I figure out how much excess I got? Well, what I'm going to have to do is I'm going to have to subtract those two, right? So I'm going to take my 4.2, which is red, moles of O2, and I'm going to subtract that green one that we calculated the first time of 3.65 moles of O2. That's what I'm going to use. I'm going to subtract those two. And if I subtract them, I'm going to get extra 0.55 moles of O2 left over. That's how much is left when I get all done. How much of the flour am I still going to have? How much of the sugar am I still going to have? How much of the salt am I still going to have after I use my 1/4 cup of chocolate chips? Right? Because this is my 1/4 cup of chocolate chips. That's controlling how much can be used and how much is going to be made. All right. All right. So from there, that one I always think is the easy one. Now the one unfortunate piece to that I'll always point out. Well, what if you had chosen? Remember the first one we did over here? All right. Well, if you did that, then all of a sudden you're going to have to do this one in order to find out how much is used. Right? If you chose this one the first time, then you didn't have to do that other one. All right, so it's kind of a flip of the coin as to whether you choose the right one, because remember, you can choose either one at the beginning. Okay, and one of the keys to this, to know as to whether or not you're using the right one is once you find out what the limiting reagent is, that was this, then in all your calculations, you got to use that number, the 7.3. And if you notice in this one over here, I used the 7.3. So therefore, this was the answer I was going to need to use in that second question. Okay? All right, so now the next question is how much product can be formed? So now we want to find out X moles of this guy that can be made. Right? So in order to do that, I use my ratio of 2 moles of H2 over 2 moles of H2O. So that came from the balanced equation, that's these two. Then I go, well, I've got 7.3 moles of H2, and I want to find out my new X moles of water. So I'm trying to find out my product. How many cookies can I make? So cross multiply 2 times X equals 2 times 7.3. Divide by 2 on both sides, and that gives me X equals 7.3. But now it's moles of H2O. That's how much product I can make. 7.3 moles of this guy can be made. Okay. So for these questions, there's always going to be 3 pieces to the question. First thing you have to do, find out who the limiting reagent is. Second thing you have to do, find out what's the excess reagent. Third part, you got to find out how much product is going to be made. So there's always going to be 3 questions to these. So tomorrow when you do the problems, right, each balanced equation, you're going to have 3 questions to do. What I just said, find the limiting reagent, find the excess reagent, find the amount of product. Okay? All right, well that's as bad as it gets in stoichiometry. So now we got to do some of these, and then we're going to do a review, and then it's going to be time for the test. And then we'll move on and get away from stoichiometry, this fun stuff. So have a great day. We'll see you.